Okay, so here's my data problem. And it says the data is given, the tables, the cost of sending a first class stamp. And this is my fault. The units is cents. And I didn't tell you that. And you guys I don't know what the true cost of a stamp is because I buy forever stamps, probably like you do, if you use stamps at all. So that's my bad. So I don't I didn't knock you on units unless you wrote something that didn't make any sense. No pun intended. So this is the year. A line, we want the years after 2000. So 2000 would be the beginning of time, would be 0. 2001 would be 1 year after 2000. 2 years after 2000. 2006 is 6 years after 2000. 2007 is 7 years after 2000. 8 years after 2000. 10 years after 2000. So that's my data set. My input variable is X, and the units is years, and it's the number of years after 2000. Output variable is Y. The units is really cents, and that's not your fault. And it is the cost of a stamp. So then it says use your graphing calculator to find a linear model for the cost of a stamp, and then in two decimal places. So the first thing I need to do is I turn my calculator on. I'm going to turn the lamp on. I can do that. And so you can see it better. And I'm going to input my data. So stat, edit. And I've got a large data set in here. So 0, enter, 1, enter, 2, enter, 6, enter, 7, enter, 8, enter, 10. And I don't need this stuff. So I'm going to delete these guys out. And I'm going to go ahead and delete these guys out because I'm not going to need them while I'm there. And then 33, 34, 37, 39, 41, 42, 44. And make sure they line up, and my two columns do line up. And do a cross check. So 033, 134, 237, 639, 741, 842, 1044. And so that when you now take a look at it, I need to do a linear regression. So stat calculate, and I need to calculate out linear regression, which is a 4. And come down and don't need any of this stuff. Just calculate, and there it is. And 2 places. I have 1.05 and 36.46. And so that Y is equal to 1.05 X plus 33.46. And the correlation coefficient is R. So it's 0.98425. So I have what I need. So I'm going to turn the light off. And it says, how good is the fit? Well, I have 1.9, so that's pretty decent. And why? Because I have 1.9, so it is close. to 1. So plus and minus 1 is a perfect fit. I'm just going to continue on to the next page. Hopefully we don't stop recording again so that this one problem is all together. So now I have my model. So that's my model. And then I come down to working with my model. And it says interpret the slope. So if I have y is equal to 1.05x plus 33.56, the slope of the line is 1.05, and this is really cents over years. And if you didn't put units, I didn't mark you wrong for it, and that's okay. So it says that we're looking at for every additional year after 2000, the cost of a stamp increased by 1.05 cents. And the fact you didn't use cents was fine. And now that I have my model here written down there, because everything's going to come off of that now, I want to move this paper and continue on. It says, use the model found in Part C to estimate in the year 2020 what the cost of the stamp's going to be. Well, 2020 is going to be 20 years after 2000. So that would say, that would be this year, 1.05 times 20 plus 33.46. So again, I'm going to use my calculator. 1.05 times 20 plus 33.46, 54 cents essentially. 54.46 cents. So that says in the year 2020, the cost of a stamp is, because we are in 220 now, 54.46 cents or 54 cents. Now this is 60 cents. So what would that mean? Well, that would mean that y equals 60, or 1.05x plus 33.46 equals 60, or 1.05x equals 60 minus 33.46, and 60 minus 33.46 is 26.54. Or x is 26.54 divided by 1.05. And that's 25.27. And this would be years after 2000. So that would be 2025. So that would say in the year 2025, the cost of a stamp will be $0.60.